So in this lesson, we were talking about dilation, scale factor, and how that helps us understand similarity. And so what we saw from the lesson is that similar figures have the same shape but different sizes. So we compare that to a couple units ago when we talked about congruent figures that have the exact same shape and the exact same size. They look identical, they're just two different shapes. For similar figures, we would see them as two of the same shape, like two triangles, two squares, whatever it may be. But we see them as different sizes, and so we compare them as similar when we start to look at their side lengths and their angles and how those relate to each other. So dilation is the act of either enlarging or reducing a figure by a certain number, or what we call a scale factor. So in a dilated figure, you're taking the side lengths and either increasing them or decreasing them, enlarging or reducing, by that scale factor, which is when you're multiplying by a particular number. So if you have a figure with a side length of 2 and the similar figure has a side length of 4, we'd say that's a scale factor of 2 because it multiplied by 2. 2 times 2 is 4. You can see there when we're finding the scale factor, we can take our new length of the similar figure divided by the original length to determine what is being multiplied there for that scale factor. And that scale factor represents a ratio. What's the ratio between the side lengths? And remember, a ratio is just a comparison of values. And so we can look at the ratio of the sides within the figure, and we can also look at between the figures. And we would find that ratio stays the same. And so the ratio between two sides should be the same as the ratio between two different sides, or two corresponding sides on the similar figures. And so the sides have a common ratio in similar figures, but the angles, they stay the same. The angles in similar figures should be the exact same. So let's look at a few check your understanding problems to see if we can make sense of this work. So in number 1, you're getting ready to move into a new house. The length of the walls of your room will be 10 feet by 12 feet. And when you look at the blueprint, the lengths of the walls in the drawing are 7.5 inches by 9 inches. What's the scale used on the blueprint? And so we have the actual lengths, 10 by 12, and we have the lengths on the picture, the blueprint, 7.5 by 9. And so what's the scale there? Well, we want to work in the same units, and so if we just focus on one of these measurements, so we'll focus on 12 feet and 9 inches, those are comparison or corresponding lengths. We want to work in the same units, so 12 feet is equal to 144 inches. So as we saw in the notes, for the scale factor, if we take our new length, 144, so if we take the actual length there, divided by the similar length on the blueprint, 9, that would give us 16. 144 divided by 9 is 16. And so what that means is it has a scale factor of 16 to 1, or 16 over 1. Okay? 16 to 1 is just a way of writing a ratio. And so we see that for every 1 inch in the blueprint, that's 16 inches in the actual length of the wall. And so that's where we see the scale factor from 9 to 12 is we would take that, whatever the inches is, times 16 to find that scale factor. On number 2, Ellie creates a unique cork coaster to sell on her Etsy shop. They come in 2 sizes, small and large. And to make these, she creates a template for the shape on her computer and then enlarges it to get the bigger size. Finding the missing dimensions on each coaster and solve for x. So we see the 2 coasters there, the smaller one and then the larger one that she creates a template for on the computer. And we want to find the unknown pieces. So there's a few missing pieces here, here, and here. And then we want to figure out what x is as well. Let's go ahead and start with x. So if you remember from the notes, it said that the angles of similar figures are the same. So this angle x here and this angle x, or this angle 124, are in corresponding positions on the coasters. And so we know x is 124 because those angles should be the same. Then if we want to find those measurements, because the side lengths are not the same, but if they're similar, then they should have a common ratio. So to figure out that common ratio, we need to look at 13 times what gives me 19.5. To figure that out, I can take 19.5 divided by 13, and that gives me 4.5, or sorry, not 4.5, 1.5, 1.5. 19.5 is equal to, or 19.5 divided by 13 is equal to 1.5. And so then we can use that fact to help us figure out the other lengths. So if this is 4.5, if we just multiply that by 1.5, that gives us 6.75. And so that's the length here, 6.75. And, oh, sorry, that was the wrong side. That doesn't give us that length. It gives us this length, because those are corresponding sides. Those are corresponding sides. So this one is 6.75. This one, the 4.3, corresponds to this side, that one. So if we take 4.3 times 1.5, that's equal to, where'd it go? I got to think about this one again. 4.3 times 4.3 times 1.5 is 6.45. And so this one is 6.45. And then if we want to figure out this side, this is the smaller side to the 14.25. And so instead of multiplying by 1.5, we'll divide by 1.5. Because if you multiply by 1.5 to get to the larger, you're dividing by 1.5 to get to the smaller. So 14.25 divided by 1.5 is 9.5. And so that's the length of this side right here, 9.5. And so that's all the missing dimensions and solve and what x is equal to. Let's do one more. Number 3, a standard Coke can have a diameter of 6.25 centimeters and a height of 12.25 centimeters. Okay, let's go ahead and label those on our can. So it can have a diameter of 6.25 and a height of 12.25. Coca-Cola is considering launching a Coca-Cola Mini with a diameter of 4 centimeters, so this would be 4. What would be the height of the new can, of the new mini can, if they're similar, if the two cans are similar? Show 2 methods for coming up with your answer. So there are a couple different ways to do this. So let's look at one method. If we know the diameter and height of the original one, and we know that these are similar, what we can do is find the ratio between the diameters. 6.25 divided by 4 is 1.5625. And so that's our scale factor for the can. And so what we would just do then is just take 12.25 divided by that scale factor, 1.5625, and that gives us 7.84 centimeters. And so that would be the height of the can. So that's one way, is to look at it look at the ratio across the figures. The other way to look at it is to look at the ratio within the figure. So what's the ratio of the height to the diameter? 12.25 divided by 6.25 is equal to 1.96. And so that means the ratio from this height to the diameter is 1.96 in the similar figure, the smaller can, as well. So I would just take 4 times 1.96. And I do times because the diameter times 1.96 gives me the larger height. And so if I take the diameter times 1.96, I can get that height, which again would be 7.84 centimeters. So all of that just practices a few of the ideas from this lesson. If you still have questions, please reach out and work together and help each other, and let me know how I can help you. Try to see if you can figure out a little bit more from this work, or otherwise ask more questions.